In this lesson, we're going to solve quadratic inequalities. So here are our steps. We're going to set the inequality equal to 0. Then we're going to factor to find the roots. Remember, roots are also x-intercepts. They're going to come in handy. Use a graph or a number line test and represent the answer in interval notation. All right, let's start this. The first one side is equal to 0. So we can factor this. I need factors of negative 15 that add up to negative 2. So I'm going to use x minus 5 and x plus 3. So my roots are whatever makes these equal 0. So that's 5 and negative 3. So there are two ways to do this. I can put these on my number line, negative 3 and 5. And we're going to check to see which section, there's 3 sections here, which section makes this a true statement. So I'm going to try 0. That's an easy one. If I plug in 0 here, 0 minus 2 or 0 minus 0 minus 15, is negative 15 greater than or equal to 0? No. So 0 did not work. So if I try something like negative 4 or positive 6, those are probably going to work. Let's put them in the factored form and see. I'm going to try negative 4. So if I put in negative 4, this gives me negative 9 and negative 1. When I multiply those together, I get positive 9. Is that greater than or equal to 0? Yes, it works. Let's put in 6 because 6 is over on this side. Just trying a number from each region. So if I put in 6, 6 minus 5 is 1. 6 plus 3 is 9. And again, is 9 greater than or equal to 0? Yes. So my answer is going to be everything less than or equal to negative 3 and everything greater than or equal to 5. I did a closed circle because I had an equal to. In interval notation, that looks like this. Negative infinity to negative 3, bracket, union, bracket, 5 to infinity. The other way to check this was to use the graph. Now I know these are my roots, 5 and negative 3. I can put them on the graph, negative 3. Now because the a value in this function was a positive 1, I know that this graph looks something like this. I don't know the exact vertex right now, but it's something like that. So the question would be, where is this graph bigger than 0? Well, here's 0. Where is it bigger than 0? Out here and out here, because the middle is below 0. So my answer would be less than or equal to negative 3, greater than or equal to 5. You can use, it says use a graph or a number line to test it. You've got both of those options. The next one. This one says x squared minus 5x is less than negative 4. So first I'm going to move everything to one side to get 0 on that side. Remember, we add 4 to move it to the other side. Now I need factors of 4 that add up to negative 5. These are the ones we always forget to check for, negative 4 and negative 1. So my roots are 4 and 1. So I can put those on my number line, 4 and 1. Now remember, we can check a coordinate from each section. So I'm going to try 0. If I put 0 in here, 0 minus 4, 0 minus 1, is 4 less than 0? No, that didn't work. Let's try maybe 2. 2 minus 4, 2 minus 1 is negative 2. Is that less than 0? Yes, that works. And you can probably predict that 5 is not going to work either, because that's kind of a pattern we've developed. 5 minus 4 is 1. 5 minus 1 is 4. Is 4 less than 0? It is not. So my answer is the middle section, everything in between. So we're going to put an open circle at 1, an open circle at 4, and it's everything in between. So in our inequality notation, that's just 1, 4. And the same thing would have happened over here if we had graphed it. Because the a value is positive, it's going like this. We want to know which part is less than 0. So here's 0. The part of the graph that's below 0 is that little section in between. All right, the next one. Okay, we've already got the equals 0 part correct. Well, let's factor this. I don't know. I don't like it when my x squared has a negative in front of it, and I notice that they're all divisible by 2. So I'm going to factor out a 2, a negative 2, and see if that makes life any easier. Well, it does. So negative 2. I need factors of negative 6 that will add up to negative 1. I'm going to go with minus 3 and plus 2. Now, when I go for my roots, the negative 2 does not impact my roots because there's no x value there. So I don't need that one. I just take my factors that have the x's in them and get 3 and negative 2 for my roots. Here's negative 2 and here's 3. Now I know they're going to be open circles. So let's check some points to see what works. I'm going to start with 0. If I put in a 0, we'll put it down here. Negative 2 times negative 3 times positive 2. That's going to give me, let's see, positive 6, positive 12. Is 12 greater than 0? It certainly is. Now, based on our pattern, do you think the outsides are going to work? Because it seems like when the inside works, the outside don't. If the outside works, then the inside doesn't. So we'll double check. Let's put in negative 3. Negative 2, if I put in negative 3, I get negative 6 times negative 1. That's negative 12, which is not bigger than 0. And I can do the same thing with positive 4. Negative 2 times 1 times 6 is negative 12, which is not greater than 0. So my answer is this in between. So I get open circles, negative 2, 3. There's my answer. Let's just look at the graph for a second and see how that would have worked. I know negative 2 and 3 are my roots. Now the a value of this one is negative. So this graph is actually going this way. And I want to know, where is the graph bigger than 0? So if I look above 0, I get the in-between space. And that's how I can tell. We've got one more. Let's make this one equal to 0. Add 9 to both sides. And when I factor this one, I get x minus 3, x minus 3. That's interesting. So my only root is 3. So that means my graph has a vertex on the x-axis at 3. Notice the a value is 1, so it must be going up. And the question is asking me, when is this less than 0? Well, let's see. Is this graph ever less than or equal to 0? Well, it's never less than 0, but it's equal to right at 3. 3 would be the only value that could make that work. Now we can check either side. If I checked a 2, let's put 0 there, or a 4. If I put 0 in, 0 minus 3, 0 minus 3, is positive 9 less than or equal to 0? No. Go to 4. 4 minus 3, 4 minus 3, is 1 less than or equal to 0? No. 3 is the only value that works here. That was an unusual case, but when you look at the graph, it makes sense. The only place where it could be equal to 0 was 3, because this graph is never less than 0. So if the question had said less than, there would be no solution. But because it says less than or equal to, that is our solution.